It's time to make this arch, I hope. So the first thing I did was scale what I had drawn, and it scaled to be about 8 feet from the apex to the center of the radius. So I rigged this up, cantilevered a little plywood out there and clamped an old 4x6 and drove a nail to the center point of the swing and started playing with it. And the actual dimension is 92¼ inches. From right there, I've got a nail over to the inside corner of that corner of the gate to the peak over there. 92¼ is real darn close. So I'm going to put some marks on these intermediate pickets so that as the piece bends, I'll have an idea when I'm getting close. But the first thing I'm going to do is draw that arc onto this concrete slab nice and tight with a pencil and start experimenting with how in the world am I going to bend this thing the hard way. I'm making this up as I go, but I'm going to strike the arc. The inside of the arc is 89¼ right here on the edge of this slab, and then I'm going to do a test bend and see how close I get before I commit myself to a 20-foot piece. "4 feet. That'll tell the tale, I hope." So here's my very scientific layout system. I'm set up, and Sai's going to be here in a few minutes. I've got the cooling gun. I've got the heat. If things go as advertised, that should be all that I need to put some kind of an arc in here using 6-inch centers for the location, the specific location, to make this thing shrink. Got my fingers crossed.
Well, as it turned out, Sai and I were not doing this quite right at all, really, because we were letting the heat travel up beyond the center line, or the neutral axis of the bar, and then I was cooling the entire perimeter of the heat and isolating the heat inside, or trapping the heat inside and away from the edge itself. The net result was about 1/4 inch of bow in the wrong direction. Back to the drawing board.
Well, I've been working for several hours, heating and cooling this piece of steel. I think you saw Sai and I try this day before yesterday, and we were just not doing it right. But I was able to call John Adolph up in Vancouver, BC, and talk to that amazing old boy, 96 or 97, and he described to me, and I told him what I was doing, and he cautioned me against heating past the neutral axis and advised me to keep the heat kind of triangular or hemispherical on the edges, and I did all that, and then he even sent me a drawing. I don't know how long it's been since he has made a drawing of a structural process, but I'm so pleased to have it. And so I came out this morning and I've been working on this, and I've got about, I don't know if you can see this, it's not a whole bunch, but I've got, I don't know, maybe 7/8 of an inch of deflection from straight. But it's too slow for what I have to do. I have to make a profound bend. And so I'm going to turn my hat around and set up a jig on the platen table, and I'm going to do half of this arch at a time, 2 10-foot pieces, and I'm going to bend them the hard way, with leverage and capturing the end and bending it around a form and hammering it straight. But I've learned so much. And so before I start setting that up, I want to show you up close and personal what happens when you take water vapor at like 100 psi, a Venturi action, pulling the water out of a tank, and remove the heat from a piece of high orange hot steel with the intention of shrinking that steel into a new shape.
So after I called John and sort of went over what had happened, he sent me a drawing. And I did better, because it became kind of clear to me that I needed to keep the heat on one side of the neutral axis carefully, and I could do that with my cooling gun, and then gradually crowd the heat back down to the edge of the bar, leaving it ultimately hot at the edge of the bar until the last second.
So I hope you can see that. But the idea is that as the edge heats up, it's pretty well cooled down now. As the edge heats up, of course, it will begin to expand. And if you can restrain that, on a table or somewhere, you don't give up that straightening effect. I haven't geared up for that. It dawned on me I have to do it a different way. But if you can restrain that and then begin to cool it, as it cools, it collapses and squeezes down and upsets the part that's hot. At least I think that's what's going on. And I think that is what John has been explaining to me. And I've watched him do it, and I have had some qualified success here. But I may be repeating myself, but I see now that the real application for this is in straightening rather than causing profound bends. Now, I have no doubt that John could, in a reasonable amount of time, when he was able to function like a 30-year-old, which lasted until he was 75, I have no doubt that he could make this happen. I also have no doubt that with my big forge, I can make it happen in a reasonable period of time. But this is always going to remain in my memory as something I've always wanted to experiment with, something that is now in a toolkit, subject to continuing, education. And if something gets bent and needs to be straightened, it's one more way to think about solving a problem that maybe nobody else in your neighborhood has any idea how to solve. That's worth something, isn't it? So one of the things that I learned as I have, took a swipe at this, is that this little sandblaster, which my dad bought 30 years ago, is terrible as a sandblaster and perfect as a water vapor generator. This thing will hold, 10 gallons or something? And this valve, this pistol grip valve, just it's perfect. Here's an example of putting off a maintenance item bites you at a critical moment. The back ribbon burner, the regulator has been maxed out at about 3 pounds of pressure. So it's been a little soft back there, right? Well, today it's maxing out at 1 pound of pressure, which means only half of my forge is hot right at the wrong moment. Lesson learned. We've got Secret Weapon Dave on the job, manning the extra tongs. We've got 1 or perhaps 2 more heats. We've nearly done it in spite of the fact that the forge is nowhere near as hot as it should be. My forge needs a little TLC. we have a qualified win here. There's a lot of little wrinkles. It's not in a plane. The curve is very close, and getting it back into a plane could change the curve, but let me show you. We didn't miss by much. When it's hot enough, it sure is easy. I think that's the last bend. Now if we get it over there and there's a couple kinks, or if we have to get it hot to get it flatter, we can do that. Because when I lay these on an anvil and try to get the little ups and downs out of them, it could change the arc. But in general, I'm going to shut the forge off, replace the regulator that has added so much time to this second part of our project, and we're going to throw that on and see if the left-hand side conforms to the line as nicely as the right-hand side. Thanks for watching Essential Craftsman, and keep up the good work.